Hello, my name is Jamie Turner and I'm Chief Engineer of Powertrain Research at Lotus Engineering.
I'm Richard Pearson, I'm a technical specialist and I'm also in the powertrain department.
We'd like to say something about this car that we've got here. It's a tri-fuel car that can burn any mixture of gasoline, ethanol and methanol. And the reason we've been doing it is to look at alternative fuels and the roles that they may play in the future in a world in which we face increasingly difficult problems with CO2 and energy security. The overwhelming weight of informed scientific opinion is that we must do something to reduce the amount of man-made CO2 that we're emitting into the atmosphere. And obviously there are very closely related issues of where the fossil fuels are distributed around the world. Of the alternatives for transportation, electrification of the vehicle fleet probably represents the best option, because that allows us to centralize the production of the energy that's distributed, and also would maximise the overall system efficiency when it comes to making use of renewable or nuclear energy. However, with batteries, problems remain with cost and weight, and there may also be some issues with material security with some of the materials that we're looking at to improve battery performance in the future. What that means is that transport is always likely to need, to some degree, a liquid energy carrier, which can be refueled very quickly into cars. So, against that background, what are the options?
Hydrogen is often put forward as the energy carrier on which our future energy economy is going to be based. Unfortunately, it poses a lot of the problems that batteries do without the advantage of energy efficiency. The containers are big, they're bulky, they're expensive and they're heavy.
In order to address the low stored energy density of hydrogen, biofuels are being investigated, and they can offer significant reductions in atmospheric CO2. Bioethanol in particular is a very, very good fuel for internal combustion engines, but biofuels do not yield much energy per unit of land, and that will obviously ultimately limit the penetration that they have in the marketplace, as well as providing a significant conflict with food. So, against that background, is there another option?
In order to address the limited possibilities that biofuels offer to address energy security problems, Lotus has been investigating the possibilities of synthesizing alcohols using CO2 and hydrogen to make methanol. Methanol is a liquid energy carrier, and that gives it the advantage of being able to utilize cheap fuel systems and provide high energy density on the vehicles. It also means it can be introduced and stored using the same infrastructure that we've got today. The concept ultimately relies on the provision of renewable hydrogen and the ability to extract CO2 from the atmosphere to make the feedstocks for the methanol.
While hydrogen can be obtained by electrolysing water using renewable electricity, we do have to develop the atmospheric CO2 extraction technology. However, researchers at the University of Southern California, at the University of Columbia and at NASA are working on atmospheric CO2 extraction and have successfully demonstrated the technology. Of course, if all the energy used in the process is still renewable, then what you have is a 100% renewable liquid energy carrier.
Providing all the energy usage in the cycle, in the production and use cycle, is renewable, then there's no net release of CO2 into the atmosphere. The blending properties of synthetic methanol, ethanol and gasoline enable us to have an evolutionary process rather than a revolutionary process in terms of providing infrastructure change, and that reduces the costs massively. Importantly for the end user, because we're using a liquid fuel, the on cost of the vehicle is very low. We estimate the order of about $100 per vehicle. That's important for providing increased mobility for developing economies without damaging the climate from CO2 release.
Of course, quite apart from the problems of making the fuel and distributing it, there are also the problems for society of how best to introduce it and to encourage its use. If society moved to taxing energy based on the energy and not on the volume taken up, then in that case one has a way to fairly compare one fuel with another. So what does all this mean in the sort of cars that we're used to nowadays? Well, if I talk now about this car here, the Exige 270e tri-fuel, I can perhaps show you some of the technology that's on board that would be required in a move to such an energy economy that we've been talking about. So if I pop the boot, we can go around and have a look at the back. So if you come down the back, I can show you the sorts of technologies that we've had to put into the car. If you look in there, you can see that there's absolutely nothing unusual compared to the sorts of cars that we drive nowadays. All the changes are in the control system and the fuel system. The rest of it is entirely as you would recognise under the bonnet of your own car at the moment. And this shows that the on-cost per vehicle to the end user is much lower than it would be for either a battery car or a hydrogen car. And the fuel can be introduced relatively simply into the marketplace. So what we've succeeded in doing is providing a potentially carbon neutral fuel that increases the performance of this car from 220 horsepower up to 270. The most important thing is that methanol is potentially a sustainable, renewable fuel that can be brought to the types of forecourts we have now for use in the types of vehicles we have today.